Okay, guys, hello. We're gonna start really quickly in a matter of minutes. Just drop some GMs into chat so I can know that you can hear me and see me well. And we're gonna kick this off. Welcome. Hello, that's perfect. Okay. Yeah, CCP, let's go. Yes, the topic for today's workshop will be to build cross-chain dApps using Chainlink CCIP. Today we're gonna be all together for 2 hours, maybe a bit less. We'll see how it's gonna go. But we're gonna talk about Chainlink CCIP, and we'll have like a hands-on intermediate workshop. So I guess it's gonna be fine for all of us to follow along. I hope you're gonna have a great time. I hope you're gonna learn something new. And yeah, let's start. So yeah, before we start, my name is Andrei Rakic. I'm one of the developer advocates at Chainlink Protocol at Chainlink Labs. And as I already said, today I'm going to talk about Chainlink CCIP, and we're going to build some cool cross-chain dApps. We're going to go through the basic CCIP examples. Then we're going to build some cross-chain NFTs, and hopefully this workshop will inspire you to build something your own using CCIP during this Constellation hackathon, the biggest hackathon so far, but in terms of submissions. So I hope it's going to be the biggest one by the quality of projects at the very end. So wishing you guys all the luck in the world. So yeah, let's go. So I saw this tweet earlier today actually, and really inspired me to talk a bit more about what Chainlink is. So I know, like I assume you guys are all like familiar with Chainlink progress, but like for the most of people, still, when I'm going to conferences and stuff like that, when I ask them like, "Hey guys, what Chainlink is?" the majority of them will say to me something like, "Yeah, it's a service for getting prices." Some of them will know about VRF automation. That's great, but Chainlink is much more than just that. So as in this tweet stated, Chainlink is much more than just the price data. Similar like Amazon is just more than just selling books, or internet is just for sending emails. So for the last year and a half, we've been pretty busy, and basically, if you follow along, Chainlink is involved to many different services and products. Basically, became a Web3 platform. Like again, example of Amazon, similar to Amazon, you can of course buy some books, or I don't know, buy something else. But if you want to create some kind of application and you need some kind of backend, well, you're going to use AWS servers, and maybe you're going to use that service, etc. Combine them, depends on your needs. Well, the same things in Web3 applies to Chainlink. So Chainlink is much more than just price feeds. Price feeds are actually a subset of the first product of this slide, called data feeds. So when it comes to data feeds, besides price feeds, there are like proof of reserve feeds, stale and volatility feeds, NFT floor prices feeds, L2 sequencers uptime feeds, etc. Okay, we all know about VRF. Automation also involved if you follow along at SmartCon 23 this year. So besides time-based automation and custom-based automation, now there are also log trigger automations. So you can spin up a decentralized Oracle network to monitor for specific events on some smart contracts, and when some smart contract emit a specific event, you can then, or a log, you can then automate it to do whatever you want. Then data streams. Data streams are like the brand new product, also launched on SmartCon, basically a way for getting prices, but with a low latency, much faster than with data feeds, basically in a minute, in a matter of like less than a second. So extremely fast, extremely powerful for like use cases in DeFi, like I don't know, like perpetual futures and stuff like that. So yeah, I highly encourage you to give it a try. They are available on testnet. For mainnet, you will need to apply to apply using like a simple type form, nothing fancy. But for hackathon, testnet is all good, and we're gonna actually have a workshop later next week, and I'm gonna host that one as well. We're gonna show you basically how you can build a DAX using data streams. Then proof of reserve feeds. I assume like you heard about them. Basically, a way to validate that some maybe great institution off chain has this amount of gold in reserve if they claim to that statement. For example, functions, extremely powerful new product that allows you to outsource some complex Solidity computation to custom JavaScript code and get signed a response of that JavaScript code execution as a callback to your calling smart contract. And finally, CCIP, which is going to be our main topic for today. So CCIP stands for Cross-Chain Interoperability Protocol, and it's launched this year on ETHCC. We already had some CCIP masterclass where we talked about chaining CCIP. Today we're gonna expand beyond that because some new stuff happened in the meantime. But yeah, basically chaining CCIP will allow you to connect different blockchains without any centralized entity in the middle that you need to trust or something similar. So there is a reason why Chainlink is called Chainlink. So if you go to ccip.chain.link, this is the main UI for using CCIP. And yeah, we're gonna spend a lot of time today at that website. Okay, cool. So what is CCIP? So first of all, to understand what CCIP is, we first need to understand the interoperability problem. So in general terms, interoperability is the ability to exchange information between different systems or networks, even if they're incompatible. So example of that can be, let's say, Twitter app. Like if you're using Twitter, it's powered by some kind of backend and database. They have a web app where you can go log in using your, I don't know, tablet or laptop and post something there. And also they have Android app and iOS app, which like are having the exact same functionalities. But the thing is that backend, and we don't know which database they're using, but that backend is written in some kind of backend language, maybe Java, Go, whatever. Then when it comes to web app, it's probably some kind of JavaScript/TypeScript framework, like I don't know, React or Vue or Angular. When it comes to mobile apps for Android, it's probably Kotlin. For iOS, it's probably Swift. I don't know, but you get the point. Like if you have like a similar example of a similar application, you can see that they are built. That applications are built using different technologies, but they're all working the same because even if they're, as say, incompatible, there are ways for other technologies which allow them basically to work as a joint machine. So yeah, same things now we want to apply to blockchains. So even though like first of all, there are different blockchains. Like you have EVM compatible blockchains like Ethereum, and there's like blockchains like Arbitrum, Optimism, Polygon, Avalanche, maybe Filecoin, etc. But Filecoin recently. Also, there's like non-EVM compatible like Solana or Polkadot. Moonbeam is like EVM Polkadot, okay, but there is Bitcoin and stuff like that. Near all of those blockchains. And now, even with the EVM compatible blockchains, like we have like Ethereum as a layer 1, and then some kind of layer 2 blockchains like as again roll-ups like Arbitrum, Optimism, or Polygon. The thing is that in reality still, because the technology is so young, is that they are like kind of like isolated islands which cannot communicate natively between themselves. Even though, for example, there is like Arbitrum is like or Optimism are like a layer 2 of Ethereum, they cannot natively pass messages between themselves. Only the layer on top, like the rollup layer, can just roll some transactions and post the report on a smart contract on Ethereum, and that's pretty much it. So, and obviously there is a natural need for majority of dApps to transfer data and value between chains, because we saw that we saw that like a year ago or something like that, when gas fees were like extremely high. We saw that blockchains do not really scale, right? So if there's like a lot of people there on using a single blockchain, the gas fees will naturally go up. And then, like, if you want to use some other blockchain, maybe it's cheaper or faster, whatever, you will need to transfer your funds from one blockchain to another. And before CCIP, this was not possible. There were some solutions called bridges, but the problem with bridges is they're centralized. So basically, you need to trust that centralized entity that will lock or burn your tokens on one side and unlock or mint them on other side. And yeah, surprise, surprise, vulnerabilities and hacks happened in the past because of that. So with Chaining CCIP, we don't have like a centralized entity. Chaining CCIP is basically a single simple interface through which dApps and Web3 entrepreneurs can securely meet all their cross-chain needs, including token transfers and arbitrary messaging. And this is really important because with bridges, you can just transfer tokens. You're using CCIP. Bridge is just one of the many use cases that you can build on top of it using Chaining CCIP. So what can you then build with Chaining CCIP? What can you do? Well, with Chaining CCIP, obviously, as I said, you can transfer tokens, and you can transfer supported tokens. That means that that there is no that means basically that if you create your own token during this hackathon, which will be like 10 minutes of work max, probably even less, you cannot natively send it using CCIP because to send tokens, there needs to be a liquidity in token pools. I will show you that in the next couple of slides. And normally there will be not enough liquidity for your new custom created token at this hackathon. However, if you still want to do something with it, you can send an arbitrary message. So arbitrary message means you can send any kind of data, and I literally mean any kind, because under the hood, it's all bytes. CCIP understands only the language of bytes, and bytes can be anything. You just need to properly encode and decode that bytes piece of data, and you can do literally whatever you want. So, example, you can send hello world message or some other string, but you can do much more. You can encode complex Solidity structs. You can encode function signatures, function calls, etc. So going back to your custom token example, if you want to transfer it using this during this hackathon, well, you can send an arbitrary data, saying that basically you can burn it on the source chain and send arbitrary data to be minted on another chain, etc., etc. Obviously, you can combine both. So you can send both tokens and data. And the good example of combining both can be like a cross-chain version of DeFi Saver app. So DeFi Saver is basically an app which monitors your DeFi positions. You know, if you're into like lending and borrowing, staking and stuff like that, because the event that you want to avoid when you're like do lending and borrowing is basically to get liquidated. So to do that, DeFi Saver has a mechanism to monitor all of these positions. But what if they want to go cross-chain, for example, and you want to create a cross-chain version of the same app? Well, you can have, for example, let's say that you're using a smart contract wallet like a constructor, but you can do with a regular one as well, and your tokens or your liquidity on one chain, but you have multiple open positions on other chains, right? So you can spin up Chainlink automation to have custom bots monitoring your open positions. And when liquidation started to approach, basically what you want to do is you will either need to repay the debt or provide more collateral. And to do that, you need your funds from that liquidity chain, from your wallet, or you have some kind of staking position somewhere where you want to unstake and send tokens, etc. So your cross-chain automation bot can just send a cross-chain message to the liquidity chain saying, "Hey, I need help fast. Send this amount of these tokens quickly." And that's an arbitrary message, like a simple message. You can encode it as a solid struct, whatever, and then you can reply immediately in a separate cross-chain message on your liquidity chain saying like, "Okay, I'm sending this amount of this token to because of this message you send me, blah blah, for this message ID," and alongside that that message you can send actually tokens, right? And then when you receive a message on other blockchain where the open position is in trouble, you can just repay your debt or provide more collateral to avoid liquidation, right? So what can CCIP sender be? Well, it can be anything, any account. So it can be externally owned account or any smart contract can send CCIP messages. Who can be CCIP receiver? Again, any externally owned account, any account, or any smart contract that implements CCIP receiver.sl. Let me clarify on that. If you send both data and tokens to an externally owned account, only tokens will arrive because externally owned account does not have code in it. But same thing will apply with a smart contract that does not implement CCIP receiver. Only tokens will arrive. Because inside CCIP receiver, there is only one function, virtual one, which needs to be implemented, which is, surprise, surprise, CCIP receive. So inside that function, you will receive the arbitrary cross-chain arbitrary message, and then you can decode it and do with it whatever you want. But you need to have that logic if you want to for example, mint cross-chain NFTs, which I'm going to show you in a minute. And yeah, how to work with CCIP? Well, we can at the moment look at CCIP as a black box. In next slide, you will see how it works under the hood, and I will explain to you briefly. But you can literally consider CCIP as a black box because there is one CCIP router smart contract per CCIP supported blockchain, which will do all the abstraction you need for you. Now imagine that you want to send a package using Post Express or something like that, like some kind of service, like or I don't know, DHL or whatever service. Basically, you will have your package, you're gonna deliver it to them, and they will do all the magic and deliver to the receiver. So it will be either transfer if you're in the same city with, I don't know, like a minibus or something like that, a van, or if it's like it's gonna be transferred by plane or by boat, by whatever. Like, but the thing is that they will do the sending of a message for you. You're just interacting with them, with the courier. So in this example, the router smart contract. So what the one thing that you need to care about it is to call CCIP router properly, to include that transaction in an X block. It's a valid transaction, does not receive. You formatted your cross-chain message correctly, and that's it. CCIP will do the magic for you, and the same thing with those Post Express companies. You will be able to monitor the status of your cross-chain message in the same way that you can monitor the status of your package. But with CCIP on ccip.chain.link, you can do that in real time, and I'll show you how to do that as well. Also, why router contract exists in the first place? Because again, they're like abstractional layer. And for example, if in the future, so for now only EVM compatible blockchains are supported, but in the future, if we add some non-even compatible, like, I don't know, Solana, Polkadot, Bitcoin, whatever, well, you don't need to worry about that. You don't need to worry about any change, actually, because the interface is same and always will be same for you. So when you deploy your CCIP powered smart contract, you don't need to update it anything. You don't need to update it, even if there is like a new additions to CCIP as a protocol, because updating a smart contract is not possible or not that trivial due to nature of a blockchain technology itself. Cool. We're now going to start with the first exercise. It's going to be a warm-up. I'm going to just show you how you can interact with the black box. We're going to write some simple minimal code needed for sending and receiving a cross-chain message, and then we're gonna come back to slides and go a bit more in depth with how chaining CCP works. And then we're going to have a cross-chain NFT example. And finally, I'm going to provide you a bunch of useful URLs for you to start building with chaining CCIP. So I'm just going to stop sharing. Oh, I can do this. Fantastic. So let me just find my remix ID really quickly. Yeah, here it is. So I'm going to just go here. Yeah, here it is. So let's just share this window. Perfect. Okay, I need to close something down. Yeah, here it is. So you should be able to see the official chaining documentation. And this is docs.chain.link page, the official chaining documentation. And when you're working with CCIP and literally any other chaining product, the official docs should always be your first stop, because official docs always have the latest version of code and always have the latest information you need and all of that stuff. So make sure to always follow along what's stated in the docs. And docs are usually always full with recommendation for best practices when using chaining CCP, but also other chainlink services. Okay, I'm gonna now go to this Gitbook, and this is basically content we created for chaining masterclass. If you liked that masterclass, make sure to follow chaining on socials. Because there will be more and more new CCP content coming. So yeah, we already covered the minimal CCP architecture. Basically, we want to see how we can use chaining CCP. And I can actually pass this URL to chat so it can be easier for you to follow along. So yeah, you should be able to see this in the chat. So yeah, going back, this is the minimal CCP architecture. So just interacting with the CCP and consider CCP as a black box. And yeah, let's get started. So in this Gitbook, you have instructions for Hardhat, Foundry, and Remix. For simplicity, I'm going to use Remix, but you can use whatever you want. Also, if you go to our Gitbook, there are starter kits specifically for CCIP. So CCP starter kit for Hardhat and also CCP starter kit for Foundry. So if you just want to build on top of these starter kits, git clone it and just do your thing. You can see here that there are 7 examples for maybe like this. Yes, 7 examples of what you can do with chaining CCIP, starting for transfer tokens from external node account to external node account. So without any smart contract, without any coding, this is essentially a cross-chain bridge, but decentralized, Also, how you can do the same thing when you're transferring from your wallet to a smart contract, then between smart contracts, how you can send and receive tokens and data, how you can just send cross-chain messages and pay with native coins, pay with link coins, and finally, how you can execute the receiver message as a function call. And this technique we're going to use to mint cross-chain NFTs later during this workshop. Okay, cool. So because we're going to use Remix, you need to go to remix.ethereum.org, which is URL for this online code editor or online code IDE. You just want to need to create a new workspace by clicking Create New Workspace. You can select blank template and just name it however you want. What I did is I name it Constellation Hackathon, and you can just click OK. I'm going to click Cancel because I already prepared my Remix ID workspace. Now I'm going to create a new file, and I'm going to name it empty.sol. And I'm going to show you in a bit why I wanted to do that. Let's zoom this a bit. So first and foremost, yes, alternatively, you can use CCIP StarterKit, both versions. So to use Chainlink CCIP, you will need at chainlink/contracts-CCIP npm package, which you can find on this URL, or you can just Google it. But the thing is that here you have different instructions how you can install it. In Remix, you just need to import it, and Remix should do the trick for you by manually downloading the contents of that package for you. So here I have basically an empty smart contract. I'm just importing the client library from this npm package, and the client library is the library that we're going to use the most today. And I'm just going to copy all of this stuff, paste it here, try to compile it. But to be able to do that, I need to be on a version 0.8.19 as specified in this smart contract. So I'm going to compile it again, and I can see that everything's green. But here I can see that the new folder called .dApps was automatically generated. You can see here. And when I open it, npm, Chainlink, contract CCIP, source, you can see that this is what we're importing. Source, 0.8 CCIP libraries, 0.8 CCIP libraries, and finally the client .sol smart contract. Okay, like this. This is the contract that we imported. Okay. Now, if I go there, I would like to show you how you can use Chainlink CCIP. So to receive cross-chain messages, if you're receiving tokens, you don't need to do anything. If you're receiving data, you just need to import CCP receive function, implement CCP receive function, and that's it. But if you want to send a cross-chain message, you always need to do one thing. And that thing is to call the CCIP send function on the router smart contract. The one that we saw on the diagram previously, the one which is a wrapper for a CCIP as a black box, right? And CCIP send accepts two parameters. The first one is destination chain selector, which is basically a unique number which serves as a CCIP identifier for a CCIP powered blockchain. So each blockchain has its own destination, its own chain selector, and it's not the same as chain ID. So for example, Ethereum mainnet is chain ID 1, but in CCIP terms is not. Actually, it's the different unique number. The thing is that all of these numbers have like the same format, which makes CCP much easier to route those messages. And there is a dedicated formula how those chain selectors are being calculated. But if you don't want to bother with that, we can go to official documentation, navigate to support the networks tab, and here, let's say for Ethereum, this is mainnet for Ethereum Sepolia, which is testnet. You can see the chain selector, which is this number, right? For Ethereum mainnet, as I said, the chain ID is 1, but chain selector is 500929. And what else? Cool. The second argument is a message, and it comes from the client library, the one we imported here. So that's what I said, that we are going to use client library a lot. And more precisely, you need to send any EVM to any message, which is a struct inside this contract, this library. So EVM to any message, you can see that you need to create this kind of struct, which has receiver, which is the address of a receiver, data, payload, arbitrary data you're sending, token amounts, an array of address for a token and amount you're sending. So if you want to transfer tokens, fee token, I'll explain to that later, and some extra arguments which you can leave using default values. We'll explain that a bit later as well. And if I scroll down all the way here, when you send a CCP message, if you're sending arbitrary data, again, you need to just implement CCIP receive function, and it just has this client any2EVM message as argument, and that's it. And that's what we're going to do today. In this first exercise, or really briefly, we're gonna send some simple cross-chain message from one blockchain to another for a better mental model and for a clear picture. You can just reference to this one. So on source blockchain, you need to call CCP send, and these are parameters. On the destination blockchain, you need to just implement CCP receive, and you will receive message in this format, any2EVM message. So you're sending EVM to any message, and you're receiving any2EVM message. And yeah, that's it. So, okay. Let's first create a CCP sender. And the reason why the name of this contract is CCP sender _ unsafe is because it's a minimal code required to send a cross-chain message. You will see how easy that is. But if you're following official docs and the rest of the content that we're going to create, you actually need to, it's advisable actually as a best practice to add some more modifiers just for security reasons. So that's why you should always follow the official documentation when you're building with Chainlink. So yeah, let's follow now steps as described in this material. So we need to close first all of this thing. Okay, maybe like this. So I need to create a new smart contract called CCP sender unsafe.sl. And first and foremost, I'm going to start with a license identifier, SBDX license identifier, and I'm going to type MIT, and I'm going to specify the Solidity compiler version. I'm going to use 0.8.19. I'm going to create a new contract, name it CCIP sender _ unsafe, and leave it as is. So if I compile this, you can see a green check mark here. That means that our environment here is properly set up, but this smart contract does not do anything at the moment. So you can see here that there are several imports. Client library, the one we imported earlier, so we're just going to copy paste that. Also, iRouter client, this is an interface for interacting with a router. And because we're creating a CCP sender, we just need to grab CCP send function from it. So we're going to import this piece of code basically using that line. And finally, you can pay for CCP fees in either native coin. Actually, it's wrapped in representation, but in a code base, you're literally going to write message.value, or using link. Because we're on testnet, for me, it's much easier to find a link, because I can grab test link tokens for various different blockchains completely for free, and I'm gonna just use link as my fee token, and that's why I'm gonna import this link token interface, basically to be able to use it. Okay, so we need client iRouter client, and link token interface. So I can just copy these 3 lines, put it here, and also if you're not following along using the URL I sent to you, I'll just paste these 3 lines into chat as well, and you can just grab it from the YouTube chat and copy paste in your code editor. Now let's go forward. So what we want to do with this code, actually, we will probably want to send something, and to do that, we need to specify the addresses of, again, a link token and the router contract, the contract that we are going to use to interact with the CCIP. So I just need to, as specified there, create 2 storage variables, and I will just need to allocate them in a constructor. So constructor is a function that is going to be executed only once during the creation of a smart contract, and I'm going to just pass the address of a link token and the address of a router contract in it, and I'm going to assign to my storage variables. And the first unsafe stuff that I'm going to do, just to save some space in my code editor to have lesser code, I'm going to approve this. I'm going to approve, grant approval to router contract to spend any amount of link tokens that this new contract will own. So I'll just send router. Yeah, you can use how many link tokens you need for handling CCIP fees. And finally, let's create a CCIP message. So we need to now code this send function, and we need to populate that EVM to any message object from client library. And yeah, let's start with that actually. And finally send it, of course. So function send, it can be public, so anyone can call it. Again, a bit unsafe, but for the sake of simplicity, this is only for this first example. So as I said, from client library, there is EVM to any message struct, and I'm going to store it in memory message, create new client EVM to any message, open parentheses like this. So let's now check if the syntax is correct. Now without new. Okay, cool. We're just gonna delete new like this. Perfect. And now we need to populate it. So the first and foremost, there is a receiver over there. So receiver, as you see, there is a receiver over there. So for receiver, we need to specify the destination address on the destination blockchain, and the most scalable way to do that is just pass that address here, and then you can specify who is the receiver anytime you send cross-chain messages. And final thing, because this is bytes, all bytes, you need to ABI encode that receiver. Again, the reason is if you want in the future to send cross-chain message from Ethereum to Bitcoin or Polkadot or whenever, or even Filecoin, like their address formats will not necessarily be the same length. So you will just encode it as a byte, send it as a byte, and decode it on the destination blockchain. Second thing is data. This is what we're gonna send. And we can hard code and send something like, I don't know, ABI encode hello world. But again, this is not particularly scalable. Also, I can do just empty if I'm not sending any message. But I think it's much more scalable, instead of hard coding the hello world text here, to just pass it again, string memory as a function argument, some text, and then depends on text, different data payload will be sent. Next up is token amounts, and because we're not sending any tokens, we're just gonna initiate the empty EVM token amount array abstract from client library. and the 0 means that just an empty array. And this is the syntax for specifying an empty array. As I said, this is the same as empty strings for data. So if you're not sending data, empty string. If you're not sending tokens, this syntax. Finally, I need to specify fee token, right? And fee token is basically going to be link, because I'm paying in link, and I have it here. So I'm just going to put link here. And finally, there is something called extra arguments. But if I put this syntax, this means that it's going to use the default values for extra arguments. And later I'll show you how you can and why you should set it manually. Depends on your use case. But for now, empty quotes means default value for extra arguments, which is essentially 2000 for gas limit, and strict is false. Okay, now that we have a message, what we need to do is actually we need to send it, right? So from our router client, router address, we need to call CCIP send function. And if we go back to this diagram, again, CCIP send accepts destination chain selector and message. We have message already. We will pass destination chain selector as a function argument as well. That means that you can send this message to multiple different blockchains, depends on your use case, instead of hard coding it inside the Solidity code. So going back, so we're here, going back here, I'm going to provide as uint64 destination chain selector. And here I will say I'm sending to this blockchain, destination chain selector, this message, and that's it. So we have 29 lines of code, which is a minimal code snippet needed for you to send a cross-chain message. And I can zoom out here so you can see how simple it is to send a cross-chain message. If you don't want to follow along, code along with me, or you had some issues to code along, so struggles, whatever, what you can do is you can go here, find CCP sender unsafe. For each contract, find these numbers. So line on ours, this is the final version of a contract. So if you follow along with this content, we added this piece of code and this piece of code and this piece. So whenever you see these numbers, this is the final version of code. So you can just click copy and paste it here, hit OK, compile it, and it's exactly the same code. Okay, cool. That was the sender. Now we need to create a receiver. So we're going to do CCIP, create a new file called CCIP receiver underscore unsafe.sol, and hit enter. So I have CCIP sender. Now I created a new file called CCIP receiver underscore unsafe. But before that, I'm going to go to check for questions. Okay, no further questions at the moment. That's perfect. So if you have any questions, feel free to drop them in the chat. I will occasionally from time to time take a look, monitor the chat, and I can answer you if you need any assistance. Okay, so far it's easy. So now let's finish with our example. So you can just now scroll a bit down here, and we need to do the same thing. We first need to specify the license identifier. We need to specify again the Solidity compiler versions. We will again need to import the client library, and we'll always deal with client library. And finally, we're going to import the CCIP receiver contract. And that CCIP receiver we're going to inherit because it consists with a function called CCIP receive, which is a virtual one, which we need to override in our example and to actually be able to see the cross-chain message. Okay, so going back here, let's speed us up a bit. SPDX license identifier MIT pragma Solidity 19 contract. CCIP receiver unsafe dot .sl like this. So we will need a client library, right? And we also need where it is, the CCIP receiver. So this line. So okay, like this, and I'm gonna paste that into the chat as well. It's clear, perfect to see that everything's clear so far. That's great. Okay, going back to Remix ID. Cool. I'm gonna compile it, and that's it. So right now, what we need to do is to inherit CCIP receiver, and now we have this error saying that it's an abstract contract, so we need to implement it, right? So you see, maybe it's not okay. There is a virtual underscore CCIP receive function that we need to implement, etc., etc. So yeah, let's do that. So because we're gonna send some kind of text, what we can do is we can create a storage variable to track latest message, and also what we can do is to track latest sender for whatever reason. Now going back to the constructor, we need to provide the address of a destination router. So CCIP receiver router, that's it. And if I go back here, so you can see here, yeah. So we need to provide the address of a router contract on the destination blockchain, because this smart contract, this receiver one, will exist on a destination blockchain and will interact with the router CCP router contract on that particular blockchain. More precisely, it will just wait for a message to arrive, but the router contract will be the one that will ping and send the package, the cross-chain message, to this smart contract. So this smart contract needs to be aware of the CCP router contract, and that's why we're providing the address of CCP router contract on the destination blockchain. Okay. Finally, what we need to do is to implement CCP receive function. So CCP receive, I'm gonna grab it like this. So I don't need this actually. I'm gonna grab it like this, just to have the correct function signature. And yeah, let's do it like this. So I'm gonna paste that to chat as well for you to follow along. Okay. Let's see, we have a question. So got a question. Every blockchain that is supporting interoperability is using the CCP receiver. Kinda. So any blockchain that supports CCP, there is a one CCP router contract deployed on that blockchain, and that's a contract that will route these cross-chain messages. If you're sending tokens from smart contract or wallet to a smart contract, whenever all combination works, you don't need to do anything because tokens will arrive. Router will pass tokens to that particular address, depends if the address is a wallet, external account, or smart contract. But if you want to receive some arbitrary data like hello world message or something more than that, you need to implement the CCP receive function, because the router will pass that message through that function. Okay, let's hide this. Depend on blockchain to pay fee may use another asset. So to pay fees for CCIP, you can use link token, obviously, or you can use a native coin on that blockchain. So for Ethereum Sepolia, that will be Sepolia ETH. For Avalanche Fuji, that will be testnet AVAX, Fuji AVAX. So from your developer point of view, that's basically message.value. So if you specify message.value, or you have native coins in your smart contract, in your sender smart contract for spending, that's how you can pay for fees, or you can do what I'm going to do, just use link token. Perfect. Okay, let's continue. Now, let's do something with that message. We're going to do pretty basic stuff. So we're going to just assign to this latest message value, and I'm going to put public keywords here. Public means that the getter function will be automatically generated. So I'm just going to assign latest message to ABI decode now, message.data, which will be a type of string, right? So when decoding, you need to provide first the data you're decoding, and then Solidity data type or Solidity data types. In our example, data type is string, and message.data, you can see data is the payload. So destination token amounts, message ID, sender, source chain selector. So this is any TVM message, we are putting data. And also latest sender is similar. So ABI decode message.sender, and data type is Solidity address. And that's it. So to receive a cross-chain message, you essentially will need around 15 lines of code. We have a bit more here because of this sender, but that's the thing. This is the minimal code required to receive an arbitrary data payload from CCIP. If you're receiving tokens, there is no need for a smart contract of any kind. Again, if you had struggles to follow along, you can just go here, hit copy, paste it here, and that's it. A bit more nicely formatted. Okay, now let's see this thing in action. We first need to prepare for deployment, and I'm going to use Avalanche Fuji C-chain to Ethereum Sepolia lane. So I'm going to send cross-chain message from Avalanche Fuji to Ethereum Sepolia, because this is by benchmarking the fastest lane, but you can do whatever you want. So by preparing, I mean you need to have some kind of some amount of native coins and some amount of link tokens on that blockchain. Because I'm going to use Avalanche Fuji, I'll need to have AVAX, which I have in my wallet, and some amount of link, which I also can get from here if I just zoom out a bit. So I'm on Avalanche Fuji. I can grab even testnet AVAX, but I don't need it. I just need 20 link. So I'm just gonna solve CAPTCHA here, hopefully. Let's see. Okay. And yeah, that should be it, right? Okay, I'm good. Send request. And 20 Avalanche Fuji links will arrive to my wallet as well, which I can use for covering CCIP fees, but I'm gonna need much less than that. Also, because I'm gonna use, again, Avalanche Fuji, maybe if you don't have it in your wallet, you can click to this URL, and it's already pre-configured to show you Avalanche Fuji testnet. But what you can do is, if you see this generic page, Google something like Avalanche Fuji. Okay, this is mainnet. Just click include testnets, and you can click on add to MetaMask, and the new chain will appear in your MetaMask. But again, you can use Sepolia to Mumbai to Arbitrum, Goerli, wherever. So everything, every combination works. The code will be absolutely the same. Okay, so we need to first deploy CCIP receiver, and I'm going to deploy to Ethereum Sepolia. So to do that, I just need to deploy contract and provide the address of a router address, because receiver, again, needs to be aware of a router on the destination blockchain. So if I go back here, I'm going to click the injected provider as environment. Maybe I need to refresh website, let's see. Okay, again, receiver, injected provider, we're good. I can see now that I'm connected to Avalanche Fuji. So how you can do that? If this is a chain ID, if you're not familiar with chain IDs, well, if I switch now in my MetaMask to Sepolia, notice the change here. Now it's 111555111, which is chain ID for Sepolia. So you are in control on which blockchain you are by specifying it in your wallet. And this is probably the most important thing for you to think about it when using CCIP. Just double check router addresses and on which blockchain you are to avoid cross-chain messages being lost. So I'm on Sepulia. I'm going to deploy CCP receiver unsafe, this one. So what I need to do is on this, even better, I just need to provide the address of a router contract. So if I follow along this content, it's over here, but as being said, maybe the address will change in the future or something like that, you don't know. So always reference official documentation. So if you go to docs.chain.link, go to CCIP, there is a supported networks tab over there. Just navigate, look for Ethereum Sepolia. Here it is. Router address for Ethereum Sepolia is this one. So just click this button, which is a copy, paste it here, and that's it. I'm gonna hit transact. MetaMask pop-up appeared. So I'm deploying a new contract on a Sepolia test network. I'm fine with that. I'm gonna hit confirm and wait for a transaction to be included in the next block. So we're monitoring terminal. You just saw a green check mark, MetaMask notification, and also CCP receiver contract appeared as a deployed one in this remix environment. If I click on get router, I can see that this is the address we provided. So we're good. We provided successfully our Sepolia or CCP router contract address. Now let's go and deploy the sender one. So to deploy CCP sender, again, it's going to be pretty simple. We're going to just provide, again, the CCP router contract now on Avalanche Fuji alongside a link address on Avalanche Fuji. The only thing that we need to do, which is mandatory, is to switch to Avalanche Fuji. Okay, so once again, go here, select CCP sender, and compile it. So compile CCP sender contract, either by combining Command S or Control S, or click this blue button, compile CCP sender unsafe smart contract. We compiled that successfully. Now we want to deploy it, but on Avalanche Fuji. We are on Ethereum Sepolia. What I need to do is to go to my MetaMask and switch from Sepolia to Avalanche Fuji C chain. I want to deploy this smart contract on Avalanche Fuji C chain. Notice the change of chain ID here. 43113 means that I'm on Avalanche Fuji C chain. Perfect. Now let's deploy this smart contract. I need to provide the address of a link token and the address of a router, CCP router contract, on Avalanche Fuji C chain. To do that, go to official documentation and find Avalanche Fuji. Here it is. So Avalanche Fuji testnet, router address, and link address. So I can pay for CCP fees in link or in native coin or its own wrapped implementation. So I'm gonna copy this address. This is a link token address. Paste it here. Also, I'm gonna copy the router address, one here, and paste it here. So I have router link, and I just need to hit deploy or this orange transact button. We're waiting for MetaMask pop-up. Here it is. We're deploying new contract on Avalanche Fuji C chain. I'm fine with that. Hit confirm. And I'm waiting for a transaction to be included into the next block. Here it is. MetaMask notification, all green, and I can see CCIP sender unsafe smart contract here. Before I hit send, I need to first fund this smart contract with some amount of Avalanche Fuji link. And to do that, we need to go to faucets.chain.link. We already went there. We got our test tokens. And now I can fund this smart contract with one link. Don't do more than one because you will need 0.1 something, so 0.2 max. We will see, depends, maybe more, maybe less, I don't know. But one is more than enough. Don't do 20 because, again, this smart contract is a minimal example. It's unsafe. Also because you cannot withdraw your tokens back. So make sure you have like a withdrawal function, and you will see that withdrawal function in all of the next examples. So what I need to do is just go to my MetaMask, send one link to my CCIP sender unsafe contract. That's it. How to do that? Okay, we're in Remix. We are on Avalanche Fuji C chain. This is the address of our smart contract. I'm going to copy it. Go to my MetaMask or your wallet of choice. I'm on Avalanche Fuji. Find link token. Here it is. This is the link token. And here, hit send. Provide the address. So, okay, this is 379. That's our contract. And specify one link. Hit next. Okay, I want to transfer one link. Perfect. And confirm. Still pending. We need to wait for a transaction to be included in the next block, which just happened. It's confirmed, pop up, all green, perfect. This smart contract now has one link in it for covering CCIP fees. And finally, let's transfer something. So first, I need to provide the receiver address. The receiver is CCIP receiver unsafe on Ethereum Sepolia. So we're just gonna paste the address, and this is the address of it. And because we're sending to Ethereum Sepolia, we are here going to provide destination chain selector to Sepolia, and combination of destination chain selector and receiver address will make sure that the message will arrive to our newly deployed CCP receiver unsafe smart contract. So receiver, again, grab the address from here, copy, paste it here. For chain selector, go again, official documentation, supported networks, and now we want to send to Ethereum Sepolia. Ethereum Sepolia is the destination blockchain, so I need to provide Ethereum Sepolia chain selector. So navigate to Ethereum Sepolia here, chain selector is here, click copy, go back, and paste it here. Finally, we need to provide some text, and I can do something like Constellation hackathon, or something like that, never matter, and hit transact. If everything's okay, MetaMask pop-up should appear. If something is wrong, we can troubleshoot that, but most likely you're either on wrong blockchain, or your sender smart contract is not funded. So be careful with that. And I'm gonna just hit confirm, and that's it. Now I'm waiting for a transaction to be included in the next block. And when I have that transaction hash, which I can grab, for example, from here, so it's still pending. And if I open MetaMask, it should be still pending. Yes, it is. Okay, perfect. Confirm transaction, and here it is here. So I can grab transaction hash from 3 different sources. What I needed for is, okay, copy. Now I will go to ccip.chain.link, hit enter, and this is the official Chainlink CCP Explorer. So over here, I'm gonna provide my transaction hash or message ID, hit enter, and I can monitor the sending of a cross-chain message in real time. So this is the unique Chainlink CCP message ID. This is the source transaction hash. So if I click this, I can see Avalanche Fuji Block Explorer saying, okay, we sent this message, we spent this amount of link, blah, blah. This is the transaction hash on Avalanche Fuji C chain. Destination transaction hash is not yet available because we're now transferring the message using CCIP. The most important thing here is this status, which we're going to monitor, says source finalized. That means that transaction was detected on the source blockchain and reached the sufficient finality. This is the moment we're waiting for. When we reach the finality, CCP will only then try to send the message on the other side. So this status will change dynamically, so you don't need to refresh the button. You can see that it's now changed to blast. Blast is what we want to see. And now we'll have that in slides. But when you see blast, that means that everything is good. There is no any abnormalities in a source blockchain, no abnormalities with ping, with the message, nothing. And now we're gonna Chainlink CCP will proceed with creation of a transaction on Ethereum Sepolia, aka destination chain, to finally deliver that message to your calling smart contract. So when you see blessed, that's always great. So we're now waiting for a success status. While we're waiting, you can see that we're transferring our message from Avalanche Fuji as a source chain to Ethereum Sepolia as a destination chain. And also you can see transaction timestamp if you want to maybe benchmark how long the sending of CCIP message will last, if that's something of interest for your use case. We can see that this message, sending this message took 2 minutes because we have a success status here, and also a new transaction hash on a Sepolia appeared here. Okay, finally, what we need to do is go back to Remix, switch to Ethereum Sepolia again. We're on Sepolia. Validate that we're on Sepolia. Yes, we are. And CCP receiver, let's now see the latest message. And here it is. Latest message is now Constellation Hackathon. That means that this piece of code, this one, executed successfully because we allocated and changed the value of our storage variable from empty string to the actual message that we sent. And also we can do the same thing for latest sender to see the actual address, which is a sender, which is 379.379. This is the smart contract that we created on Avalanche Fuji. So going back here, do we have any questions? Let's see the chat. Okay. I will adapt for my uni. It's still in prototype for donations degrees. So if I implement CCIP, can I accept various tokens other than ETH? You can accept CCP supported tokens. So to do that, go to official documentation. Let's see where it is, official documentation. And over there should be a reference to tokens. Let's just find it. This is for transferring tokens. Okay, not yet. Okay, we're gonna navigate to that URL later, but what we can do is if you go to supported networks, and let's say you're on Ethereum Sepolia, supported networks, this is for fees. These are the tokens that you can send, for example, from Ethereum Sepolia to Optimism Goerli, CCP BNM, CCP LNM. We're gonna talk about them in a minute. So you can, these are like supported tokens on this particular lane. So you can use them as well for receiving for your prototype. Okay. Which is the average to receive a message? If you mean time, it depends on the lane, and you're understanding a bit why. So it was like 2-3 minutes for Fuji to Sepolia. Sepolia to Fuji will be a bit longer. The thing is that we need to first wait for a finality to happen on source blockchain before attempting to send cross-chain message. So finality times are different for Avalanche Fuji and Ethereum Sepolia and Polygon Mobile and all of different blockchains. Depends on the nature of a blockchain, of course. So basically, finality means that transaction where our cross-chain message is cannot be rolled back, or it's on a right fork and then on a canonical chain, and then we are sure that we can now transfer it to the destination blockchain. So that's why it depends on that, but it's definitely more, much less than like 7 days for traditional bridges or 40 minutes and stuff like that. Okay, cool. Okay, cool. No further questions. That's awesome. Let's now go back to our presentation. So we saw Chainlink CCP in action. We saw the basic example, but what just happened under the hood? Why we were waiting for the finality status, why we were waiting for that blast tag, and why did the destination transaction hash appeared only after 2 minutes. So now we're going to take a look at this black box, and you can see here that again sender can be whatever, smart contracts, running account, whatever, and you can transfer. We're actually looking from left to right, and you can transfer data, tokens, or both. To do that, you're interacting with a router smart contract, and that's it. You're stopping there because now from that point everything's automatic, right? So CCP router contract will communicate with another contract called on-ramp contract, which will handle token transfers. So if you're transferring tokens, which we didn't in the previous example, so no work were necessary there, you will basically either lock them or burn them on a source blockchain. There are three different mechanisms for token sending. Two of them are live. The third one is coming soon. For all three of them, you can find details about how they work in both official documentation and the Git book I sent to you. After that, there is this off-chain component part. So if we take a look or remember how Chainlink works with data feeds or with VRF or whatever, there is one DAwn. DAwn stands for Decentralized Oracle Network, and it's basically a collection of nodes, independent nodes that needs to reach a consensus on some work or some off-chain data. And when it comes to prices, it's just the consensus of getting a price, but it's a one DAwn basically. It will have this amount of nodes in it, and there will be one node that will send the actual callback to the blockchain, etc. With CCIP, we have three DAWNs. Instead of one DAWN, there are three DAWNs for the extra layer of security, right? So in the middle of this picture is a committing DAWN. Committing DAWN is listening for transactions on a source blockchain. And when it notices a transaction from your smart contract or yourself to the router contract, it will figure it out is a CCP cross-chain transaction and will create a Merkle tree of those transactions when it got finalized. So it waits for a finalized RPC tag. When the transaction is finalized, it will create a mini Merkle tree with it and post it to another smart contract on the source blockchain, right? There is this thing called that smart contract is not present on the diagram. There is this thing called risk management network, which is another DAWN that again monitors both source blockchain and the destination blockchain. So when a new CCP cross-chain transaction happened, it will also this risk management network will also monitor and figure it out and notice it, and will also create a separate Merkle tree based on that finality tag. By separate Merkle tree, I mean every single node in the DAWN will create a Merkle tree for it. Then it will listen and monitor destination blockchain to see the Merkle tree reported by a committed DAWN. Then the risk management network will compare its own Merkle tree and the Merkle tree reported by a committing DAWN. And each single node in the DAWN will now vote. If the Merkle tree is the same, they will vote for bless. Or if something's wrong, they can vote with curse. So when we see that, and when we actually saw that blessed tag, that meant that risk management network blessed or approved the execution of a sending of a cross-chain message. So if the status is cursed, or the majority of network vote as a cursed, everything stops, and the cross-chain message will never be delivered to the destination blockchain because, again, maybe there is something wrong with the source blockchain, some finality, chain reorg, whatever, and it's not safe to transfer tokens or data or data. Then there is this executing done, which monitors, again, both source blockchain and the destination blockchain. When executing done, see the event that the status is blessed from a risk management network, it will attempt to deliver the cross-chain message. First, it will communicate with an off-ramp contract. If there are transferring of tokens, depend on the mechanism, off-ramp contract will either mint or unlock them. In our example, that wasn't the case because we just sent a simple message, and then off-ramp contract will call the router contract. Router contract will deliver data and or tokens to the receiver. In our case, that was CCP receiver contract, and then we had a success status on a CCP Explorer, and we were able to see the destination blockchain transaction hash. And also when we called that latest message view function, we saw the actual Constellation workshop string as a received message. And that's what happened under the hood during those previous 2 and something minutes while we were monitoring the CCP, the chain.link UI. Of course, as I already said, you can just think of CCIP as a black box. Just be aware of routers, and to be able to use it, you don't need to worry about all of this stuff in the background. If you want to know about them, to know more about them, that's why we had that previous slide, so I can explain to you. You can read a lot about underlying mechanism and architecture in our docs. But if you consider CCP as an international flight, for example, and you're flying from New York, from JFK Airport to Barcelona Airport, El Prat for Smart Contract 3, well, what will happen with your luggage? You're gonna go to the very first check. You're just gonna provide your passport to see that you got a ticket, blah, blah. They're gonna check you in, and you're gonna provide your luggage, right? And then your luggage will go to the different routes, through different routes, different canals, also will be checked by security. And that's something you don't usually see. And in 99% you will not see it, but sometimes you will see a note that says something like, yeah, hey, your luggage were opened because there was something suspicious with it, so we needed to open to check it out, blah, blah, or no. But the thing is that after you fly to Barcelona and arrive there and go through passport control and all of that stuff, finally you will be able to grab your luggage back. So if you think about all of these steps as like security checks, passport checks, as like committing done, risk management network, and executing done, that's similar as an international flight, right? And when it comes to the time needed for you to send the cross-chain message from one blockchain to another, again, it really depends of whether you're flying from New York to Barcelona or from Madrid or London to Barcelona, because Madrid or London are there is a much shorter distance between them than between New York and Barcelona. And the same thing applies with if you're sending from Fuji to Sepolia and Sepolia to Fuji, the time will be different. Same like if you're flying from New York to Barcelona and to Barcelona to New York, it will be 10 or 8 hours, depends on if you're flying to west or to east. Again, because of the nature of planet Earth, let's say. So I hope this was clear to you. If you have any questions, feel free to drop them in the chat. I'm going to wait for a minute. And if not, we're going to continue with example number 2. And after that, we're going to wrap our workshop for today. And I'm going to give you some time back so you can build something amazing using CCIP. Okay, I'm just going to monitor for a chat for a bit. Perfect, no questions. That's awesome to hear. Let's now start with exercise number 2. So for exercise number 2, we need again our web browser. And we're going to use this example of cross-chain NFT minting. So this is a Hardhat project. Also, if you want to have a Foundry version, if you go to CCP StartKit Foundry, example number 7, it's pretty much the same thing. And also, if we want to do this in Remix, you will need to just copy paste some code from here, which we're going to do. Okay, so what we're building. We're building a system like this. How can you see this like this? Oh, okay, never mind. So we want to imagine a situation where there is a new fancy NFT collection and you want to mint it, but you need to pay for minting, right? And you have some tokens on Ethereum, Sepolia, and that collection is on Polygon Mumbai, right? What you need to do is you need to, before CCIP, you will need to go to official, or unofficial, some kind of bridge to bridge funds from Sepolia to Mumbai. Then to wait for funds to appear there, then you will have some kind of some amount of funds for minting on Polygon Mumbai. You're gonna mint it, and then maybe you'll want to send back your funds from Mumbai to Sepolia, and it's like a long process. Now with CCIP, option number one is you can transfer tokens much faster and just use it. Or option number 2 is to create a system like this. So your dApp can have a mechanism to have on a blockchain where the NFT collection is, like if you have this, I cannot see it right. This is like an NFT smart contract here, and there is like a destination minter there, and that destination minter can be a smart contract that can receive CCP messages, and then you can just send messages from source blockchain. You don't need to create a smart contract for that. I'll just create it because it's easier. In theory, you can just interact with the router contract, right? So if I go back here once again and find the router contract, whatever, this is the router contract, right? You can go to Explorer, this is the router one, write contract, and here is CCIP send. So you can send message from here, right? So you can specify receiver, data, token amounts, fee token, extra arguments, payable amount if you're paying with native coin. By the way, if you're paying with native coin, fee token address is address 0. This one, okay? If not, it's going to be a link address. Then destination setting selector, and boom, you can send it from here without ever need to create a smart contract. But we're going to do that for the sake of practice. Okay, now let's see what we have in this repo. Simple README for usage, and a couple predefined Hardhat scripts that will deploy this smart contract, that will fund it, and that will finally deploy receiver and fund it, and finally minted by call the cross-chain mint function. This is a screenshot of CCP Explorer, which we saw in the example number 1. And finally, you'll be able to see it on OpenSea, something like this. This picture is not maybe the prettiest one, but doesn't matter. Okay, you have these examples and steps for Hardhat and Foundry. I will do this in Remix. So first and foremost, we have source minter, my NFT, and destination minter. And also inside utils folder, there is this withdraw function, withdraw smart contract. So withdraw smart contract is nothing more than a smart contract that you will just inherit, and it will allow you and have functionality for you to withdraw native coins or any tokens in it, probably just a link one that you're gonna fund and send for covering the CCP fees. So yeah, you will always want to have this kind of functionality just to avoid locking your contracts, locking your tokens in smart contract. Okay, we're going to start with the destination blockchain once again. So we first need to deploy my NFT. Actually, we're not going to deploy it. Apologies. We're going to deploy it here. But let's examine the content of my NFT .sl file. So you can see here that it's like a pretty basic, pretty standard NFT like a minimal code required for an ERC-721 smart contract, right? So it used OpenZeppelins to import this ERC-721 URI storage smart contract, and also ownable for handling minting privileges, access control. So only owner means that only the owner of this smart contract will be able to call the mint function, and that's why we're gonna deploy it inside the destination minter, so the owner is actually the destination minter smart contract. But going back here, so it has token URI, which is hard-coded to that not particularly pretty image. Also storage ID, storage variable for token ID, and that's pretty much it. It has this mint function which will mint a new token, set the token URI, and increment the token ID. Pretty standard stuff. What destination minter will do? Destination minter will implement CCIP receiver smart contract, and also will deploy my NFT inside constructor. And now it has the CCIP receive function. So if you want to cross-chainly mint smart contract, mint a new NFT, you will just send a cross-chain message to the destination minter as a receiver. And inside this CCIP receive function, we have a call to the NFT smart contract. Call is like a call opcode with message.data. So what we are sending here, and we will make sure that the call was a success so we can emit an event. So what we are sending, well, calling actually. Well, in source minter, you have several stuff. You have this withdraw function, which will allow you to just withdraw tokens. You have this enum to specify in whether you're paying for CCIP fees in native coin or in link. Again, you have storage variables for router and link. And again, you're gonna set it in constructor. And then there is this mint function, which is slightly longer than the one for sending in the previous example. So we're providing, again, destination chain selector, receiver, and finally, the enum for paying fees in. Because this is enum, it will not pass native or link, we're gonna pass 0 or 1. So enum, it's 0, 1, 2, whatever. This is familiar to us. We're gonna create a new EVM to any message object, right? We need to provide, again, a receiver address, which is this one, right? Actually, it's gonna be the address of the destination minter smart contract. Then data. We are now not sending some simple string. We're not sending any tokens again, but we are sending encoded function selector, also with some function arguments. So we're basically saying by this, encode this in a bytes format, so the destination when call function will call this function, mint one, with this argument, message.sender. We're gonna mint the new NFT on the destination blockchain to whichever address calls this mint function here on a source blockchain. Again, we're not sending any tokens. There is no extra argument needed. And for fee token, it really depends on enum, whether we're gonna pay for fees in link or in native. So if you're paying in native coins, you will provide address 0. Okay, finally, we're gonna calculate the fee. So router also has this really handy get fee function, which will just, you're gonna provide, again, destination chain selector and message, and it will just calculate the fee for you. So now you can approve the exact amount that you want to spend, right? And send the message. Or here, when you're sending with native coins, the syntax is a bit different. You're just gonna provide value for fee here, and that's it. Finally, emitting an event, and that'll be it. So let's now implement this in Remix. Before we start, just quickly check the awesome. No. Okay, perfect. No questions about the workshop. That's always nice to see. And now let's just copy the content of this repo. So I guess this is okay. Okay, cool. So we need to have utils folder and init withdraw.sol, compile it. Oh, good, perfect. We have a bunch of artifacts. Perfect. Actually, like this. And then what we need my NFT.sol. We need destination minter.sol and source minter.sol. Okay, and let's now grab the content of these contracts. So destination minter, really quickly. Destination minter is here. It's error because it's not aware of my NFT. So let's give it to the NFT. My NFT here. Okay. Maybe it has something with a version. Okay, I need to go to a different version. Okay. Okay, we can do it like this. 20. Okay, cool. Now let's see what's going on. That's not right. Okay, cool. I know what's going on. Because of the recent upgrade of OpenZeppelin, there is a new contract here. So let's see how I can specify the correct version of OpenZeppelin. Let's see, inside package.json, there should be 0.61. Okay. If I want to do maybe like this, let's see what's going to happen. I hope. Okay, this is not the right syntax. Never mind. We're not gonna trouble debugging this contract now. What we can do instead is we can just use the repo we have. Okay, so to do that, go to code. And because it's a Hardhat project, I'm gonna just clone it. So go here, open integrated terminal, and share integrated terminal just a bit. So I'll need to stop sharing this screen. Okay, there it is. And let's see, share screen, window, desktop. Okay, cool. So you should be able to see my integrated terminal, right? What I'm going to do is that I'm going to type git clone and clone the actual repo here and cd into it. CCIP cross chain NFT, here it is. So it's the same thing. We don't bother with remix and all that stuff. We have our project here. And what we need to do is we should probably need to just install it. Let's see really quickly the instructions in README. Yes, we need to install it. So npm install. Okay, cool. And we need to type npx hardhat compile. Perfect. So what I did git clone this. I did npm install, and I did npx hardhat compile. Perfect. Now let's specify our environment variables. So basically, we need to provide our private key, our RPC URL for source blockchain, which can be Avalanche Fuji, and RPC URL for the destination blockchain, which again can be Ethereum Sepolia. So how to do that? We first need to type something like this: npx env enc set dash pw. Okay, and set some password. Okay. So npx env enc set bw. Now let's set the actual values, right? So that's everything you can find in the official README, but we're gonna do it together. So I'm gonna type npx env enc set, and I will need to set 3 different variables. So the first one will be my private key, right? And I will need to paste my private key here, right? So I'm just gonna do some dummy stuff. Then the second one is Ethereum, Sepolia RPC URL, and do whatever. And finally, Avalanche Fuji RPC URL. Hit enter. And would I like to set another variable? No. So I'm going to hit enter one more time to finish. And now if we do npx env enc view, I can see that something was generated, right? Fuji URL, blah, blah. But if I open this inside Visual Studio Code, which I'm going to do now, and you can use whatever code editor you want, we will notice one interesting thing. Let me just share my Visual Studio Code instead of terminal. Share screen. We can do window. You should be able to see. Yeah, you should be able to see it. I'm going to zoom it a bit. If you take a look at this green piece here, it's a new file generated, which has this environment variable, but they're encrypted. So you cannot see it without a password. That's why you set a password. And when you run npx env-enc view, you were able to decode it in a human readable string. But in reality, you will just have these encrypted variables, and if you accidentally push that to Git repo, you're fine. No one will be able to decode it without your password. So that's something that I suggest you to use instead of just plain .env files. Now let's just follow what we have here inside README. Okay, we will need to run some scripts. Let's see. Once again, npx env enc view. Okay, perfect. Everything's great. Npx hardhead compile. So we'll need to just run a couple of tasks. But before that, what I'm gonna do is, well, I'm gonna grab my own environment variables and paste it here as encrypted, so you cannot see my actual private key, RPC URLs, and stuff like that. So I'm gonna just leave it here on a minute to grab them. If you have any questions, now is the time to ask while we have this short break, really short break, because I already have my environment variables. Perfect. Cool. And I will now, let's see, just to close this thing up. Sorry about this. Cool. I will now share my screen again. So share screen, what we're looking for. Visual Studio Code, right? And you should be able to see Visual Studio Code. Yes, perfect. Let's now see how we can do the same thing that we done in Remix, but using predefined hardhead tasks here. So I can first deploy my NFT and destination minter by running npx hardhead destination deploy destination minter task, and I'm gonna just hit enter. Okay, the thing is that I completely forgot that if I want to do that on Avalanche Fuji, well, I need to provide the network. So I'm going to repeat the process and provide the network flag, because I cannot do this on Hardhat network local one, obviously. Hit enter. So we can now monitor what's going on here. So we are attempting to deploy first my NFT smart contract on Avalanche Fuji using this address. You have this tiny loader here. Okay, NFT contract was deployed. Now we're deploying destination minter. So we now want to grant the minter role to destination minter smart contract. And everything's green. That's what we want to see. So deploy destination minter. Now let's deploy the source minter. So we're going to deploy it on Ethereum Sepolia. So to do that, well, same thing. Just paste this command here and specify the Ethereum Sepolia network as a flag. So yeah, we're just attempting to deploy source minter contract now. It has been deployed. Great. Let's continue now. The third thing is fund management, or fee management, actually. So we will need to fill source minter with either Sepolia 8 or CCIP link. So let's say that we want now for a change to do Sepolia 8. So we're gonna do npx hardhat fill sender command. Okay. I think this will be easier for us to follow along. So npx hardhat fill sender address. Provide the address of a sender, which is a source minter, right? Put it here. Source minter. Then blockchain. We are funding this on Ethereum Sepolia. Then amount. So there's a amount, and because we're sending 0.01, we're gonna do 1 and 17 zeros. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And finally, we are gonna pay for fees in native. Hit enter. And yeah, wait for this transaction now to be included into the next block. So we're attempting to send this amount of Ethereum Sepolia native coins to Ethereum Sepolia ETH, and we did that. Perfect. Finally, let's finally mint our cross-chain NFT. So to do that, we're going to type npx hardhat cross-chain mint. Source minter is the address of a source minter, this one. Source blockchain is Ethereum Sepolia. Destination blockchain is Avalanche Fuji. Destination minter is, let's see, this address. And we are paying for fees in native. Pay fees in native. Hit enter. And yeah, wait for this transaction now to be included in the next block on Ethereum Sepolia. It's still running. That's usually great. Yes. And we can see now that mint request has been sent. Transaction hash is this one. So I'm just gonna grab it, stop sharing this screen now, go to share screen. We're gonna do CCP Explorer, right? Go to CCP Explorer. Here it is. And if I go to CCP Explorer, paste the transaction here, And we can see that now we're waiting for finality on Ethereum Sepolia, and same thing, we're gonna wait for this message to be sent. And finally, you can go to OpenSea and see a new NFT being minted on Ethereum Sepolia. Perfect. That'll be it actually for this exercise. So finally, we have time for questions. And also, while we're here listening for questions, there is this QR code for feedback form, so you can just scan it and fill a tiny type form, really short, just to make sure that, just to say to us whether you liked or disliked this workshop, what do you like the most, what you didn't like, was the pace good, etc. So we can make this workshops even better in future for you, because again, these workshops are for you. While we're waiting for that, okay, here is the syntax for all the imports in Remix. Don't see it. Maybe it's somewhere in the chat, but basically what happened is that OpenZeppelin released a new major upgrade of their smart contract. And when you copy paste stuff to Remix, it will always download the latest version. And because these contracts were not written with the latest version, they were deployed during the launch at ITCC. We will need to specify the exact version if back in JSON. I'm sure you already know about that. So yeah, that was the only reason why. But again, as I said, you can use CCIP with any development framework you want. While we are here, actually, I will also want to share something with you. So we're waiting for finality here. Okay. Where is that? Yes. So when you're done with this workshop, also if you go to this URL in Gitbook, I'm gonna paste it in the chat as well. You can find a bunch of other useful resources which can help you build with CCIP. So again, starter kits, old Hardhat and Foundry versions with these 7 examples. I think these 7 examples actually cover all of the majority of all functionalities and everything that's possible with CCIP. Then bunch of cross-chain applications. So if you click on this URL, it will navigate you to the blog, the chain.link, like a huge blog post explaining in detail how you can use CCIP to actually, let's see it, to build a bunch of other stuff. So it's a bit longer, but here I think this one can really inspire you to build something really really useful during this hackathon. So the code bases mentioned in this blog post are this one for cross-chain NFT minting, which we just did, then the one from cross-chain DeFi landing. There is a tic-tac-toe game. You can create a bunch of other cross-chain games. Cross-chain ENS is like a name service, but you can have those names on multiple different chains, and also cross-chain liquidation saver and interest rate optimizer, which combines CCIP with automation and functions. It's a bit more advanced project, but as you already know, combining multiple chaining services can give you some extra points and level up the complexity of your app, which is always nice. Also, inside this contract CCIP npm package, there are a couple of predefined applications and examples, if you wish. And of course, finally, a bunch of examples from official chain documentation. I think this is a bit outdated. They've added some more examples. So I guess this page will serve you well. And yeah, so once again, feedback form, please fill this out. Question: my team is planning to use CCIP. This is perfect. Thank you. Really appreciate. I'm glad you like these resources and this workshop. Okay, final for questions. I don't see any in the chat, so let's finally wrap this up. Thank you so much for staying for almost 2 hours with us during this workshop. I wish you luck at the Constellation Hackathon. For the next workshop, there is a schedule at the official webpage on hack.chain.link. And I will see you in a week where we're going to do data streams, where we're going to do a workshop using data streams. We're going to create a DEX using a new and faster prices source from Chainlink. Thank you guys. Enjoy.